Hello guys and welcome to another video, and the topic is aircraft wing structure. In the previous video we saw how an airplane actually flies with the help of wings. But have you ever given a thought as to how this beauty is made? Just like our body has a skeleton, the wings are also made the same way, and since the wings of an aircraft are responsible for getting it off the ground, the wings must adhere to the aerodynamic shape. So its skeleton must be made in such a way so that not only it doesn't change the aerodynamic characteristics of the wing, but also the skeleton provides the required strength so that the wing, when subjected to different loads in air and or ground, it's able to sustain itself without causing any damage. So without taking much of your time, let's check out how the whole wing is shaped like one. Well, for giving that beautiful aerofoil shape to the whole wing, we require a number of ribs. Hold on, skeleton? Ribs? What's going on? If you feel this is going towards the direction of biology, there's nothing to worry about. Every aircraft structural engineer considers himself as an orthopedic surgeon. JK. Now coming back to ribs, so these are nothing but structural members which are shaped like an airfoil, and they basically give that beautiful shape to the wing. The ribs are usually made of metal, but now these days, emphasis is being given on composite material ribs, since composite materials have a high strength to weight ratio, basically either more strength or less weight or both. The ribs are placed at small regular intervals and their number depend from wing to wing. Now we have the stringers, which is basically a stiffening member and goes through these ribs, and they are mainly there to transmit the aerodynamic loads. No idea about aerodynamic loads? Well, then check out my previous video on how an aircraft actually flies. The link is given in the description below. The aerodynamic loads get transmitted from the wing skin or the surface of the wing to the ribs and spars via the stringers. Spars? What are they? So they are the main structural members along the span of the wing. Their role is to take the aerodynamic loads which are imposed on the wings when in air, and also support the weight of wings while on ground. Bending loads, drag loads, torsion loads, etc. are some loads which this member must hold. For withstanding these loads effectively, 2 to 3 spars, namely the front spar, mid spar and rear spar, must be installed. Hang on, why am I discussing the main member at a later stage? Well, then how would I be able to relate a body skeleton with the airplane wing had I not discussed about the ribs first? So coming back, the ribs, stringers and spars mainly make up the internal structure of the wing, just like a skeleton. And now to cover the skeleton or the internal structure in case of a wing, a skin must be put over it to keep the surface smooth, and this is nothing but the wing skin. Completing the internal structure, let's check out some external members which are there on the wing. So first, let's see the flaps. Reminds you of Flappy Bird game? My score was not even above 100. Now, flaps are basically used to produce sufficient lift force even at lower velocities, and that's why they are also known as high lifting devices. How they work is something which I'll discuss later in one of my upcoming videos. But for now, we can just know that they are used to increase the lift at a particular airspeed. Their location is at the trailing edge of the wing, as can be seen. Next come the slats. So these are nothing but flaps located at the leading edge of the wing, and their role is again same, that is to increase lift at a particular airspeed. The flaps and slats are normally used while landing and takeoff, since while landing you need to have sufficient lift at low speeds, and while takeoff you need to get off the ground as fast as possible, and that can only be done if you have sufficient lift force. Now before telling you the next component, let me ask you a question. Have you seen those sharp pods under the wing and wondered what they actually are? So these are basically coverings of the flap actuators, and these actuators are nothing but a component for moving the flap. We cover these actuators to minimize the drag. Pretty cool, isn't it? Now we have somehow managed to increase the lift, but an engineer is never satisfied. During the touchdown of the aircraft, it has a relatively high velocity, and to get off the runway, you need to slow down. Brakes are not sufficient enough, Although applying full brakes might stop the airplane, but then the tires may catch fire. And trust me, that's really dangerous. So the engineer thought of spoiling the airflow, and that is done by the spoilers, also known as the air brakes. These are located on top of the wing and they increase the drag or the resistance force by disturbing the airflow. As simple as 2 plus 2. Next, we have the ailerons. Just like when we want to turn a car to left or right, we use steering wheel and that turns the forward tires to the respective direction. Similarly, if a pilot wants to roll or bank the aircraft to left or right, the ailerons come to rescue. With these, the aircraft can roll and it is achieved by differential movement of the ailerons, that is one aileron up and one aileron down. For banking right, the right wing aileron is deflected up, and for banking left, the left wing aileron is deflected up. Now we have a weird word component, the flaperons. Nothing to be scared of. They basically combine the characteristics of both the flaps and ailerons, hence the name. Lastly, we have the winglets. Now these are installed in some planes at the wingtip to minimize the drag and improve aircraft handling. Just simple as that. How they work is something which I'll again discuss in one of my upcoming videos. So that's all for today about the technical aspects of an aircraft wing. If you have any queries, questions, please do let me know in the comment section below. Until then, see you next time in another video with another exciting topic.